This is what we're going to be building today. This is the fully finished product. It is currently maintaining a proper moisture level inside this plant. Oh, look at that. It when I pulled it out in the air, I thought it was too dry, so it's kicked it on. And there it goes, it's pumping. So this is the finished product. And we're going to walk through how this was built. The majority of the circuit is going to be built with these components. We have a solar panel, a pump naturally, and the Arduino, which will be the brain of our project, and then a few small components that we will use to assemble this entire circuit. Okay, so the reason for building this project is simple. I would like to keep my houseplants watered at the right level, and I would like to build a machine that will do that for me. In order to achieve those goals, we need to have a few pretty basic things. The first of which is to measure the amount of moisture that's currently in the soil, then decide if that is below or above a threshold of moisture that we want to keep the plant healthy, and either turn on the pump or don't turn on the pump for a period of time, then measure the soil again, which starts the whole process over. In order to achieve those goals, we also need power, and I don't think it's ideal to have a house watering plant system that needs to be plugged in. So this needs to run on battery and be recharged by a small solar panel that's included on the unit. Because if you're watering your plant, it's pretty likely that your watering system will also have access to the same sunlight. And in order to achieve those goals, we're going to follow this pretty straightforward design. At least I think it's straightforward. Essentially what we have here is we have a solar panel that charges a 6-volt battery, and we have a charge controller circuit which makes sure that we safely charge the battery, and once the battery has charged up to a certain level, the circuit slowly stops charging so we don't overcharge and damage anything. And then when the battery drains, the circuit starts up again, keeping the whole system running. Then for the brains of our system, we have an Arduino Pro Mini, which will be running some custom C code that will manage our entire system. To measure the moisture in the soil, we have a capacitive soil moisture sensor, which sends an analog signal to our Arduino, which then measures it and decides whether or not to turn on the pump or leave it. For user input, we have a single variable resistor, which is basically just a knob that the user can turn to make the environment more moist or more dry. To reflect the level that the user has chosen, we have 3 blue LEDs, which increase from right to left and also intensity to reflect. Do I want a more wet environment? All the lights will be turned on fully bright. Do I want a more dry environment? Maybe only 1 or 2 of the lights will be turned on and they'll be more dim. Additionally, for user feedback, there is a multicolored LED which reflects certain states of the system. It turns red when the environment is too dry. It turns blue while it's pumping. It turns back to green when the desired conditions have been met. And if for some reason the solar panel has been out of the sun for days, for too long, and the battery is draining, it'll blink orange to let the user know that something's not quite right and you need to intervene and maybe change the position of the solar panel. So this is essentially how the circuit is going to function. And now let's move on to the build process. So we got the platform. I think we're just going to go ahead. Everything fits together properly. So now what we're going to do is assemble the prototype PCB circuit, test that circuit, slap it on here, and get this thing running. Okay, I have just quickly wired up most of the circuit onto a couple breadboards here just to spot check and make sure everything works. If I touch the moisture sensor with my hand, I can see that it's changing, which is good. So now we're going to hook up the solar panel, the batteries, and the pump and see if everything works. This is exciting. Okay, so I have flashed the firmware to the Arduino Pro Mini. So the same firmware that's running on the Mega 2650 is running on the Mini. All of the features are working on both. Right now, if I change the threshold, you can hear the relay click, which would turn the pump on. And then as we change the threshold again, turns the pump back off. The same functionality should be working over here. Let me see if I increase the threshold. Okay, now that we've got a bit of a cleaner working space here, we have the Pro Mini wired up. The circuit works. If I modify the threshold here, the indicator's changing. The threshold indicators are going up, and then you saw this, the pump indicator change. This guy's not in any water, so that's why it changed so quickly. And then if we go back down, oh, going the wrong way. Kind of jumps. But the principal function of the circuit works. We can adjust the moisture. The indicators reflect the threshold level, and then the pump light indicates that we're turning the pump on and off. Now I need to connect the actual wiring for the pump and connect the pump, which is as of disconnected, and also wire up the solar power, which is functioning, and even on my little desk is getting about 0.2 volts, which is cool. Yes, so I'm going to try to run this on standalone power and make sure everything works, and then if that works, I'm going to debug with the serial monitor to try to figure out why those indicator lights jump so quickly. One note about this circuit, this extra Arduino that we have here doesn't actually have a processor in it. It's been removed, and that's because the Arduino Pro Minis don't have a USB port. So in order to flash it, remove the processor from another Arduino, and you chain the RX and TX pins from this Arduino into the Pro Mini, and then you can use the USB port here to flash the firmware. So you can just sort of ignore this when we're looking at the rest of the circuit. Okay, so the circuit is wired up. It's running entirely on battery power. I think I have sort of worked out what bugs were left. You can see there as I change the moisture threshold level, it kicks the pump on and off. I've also added a flyback diode, so when the relay gate flips, the voltage spike doesn't harm the Arduino. And then I've also added a couple capacitors, just so the voltage remains stable in the circuit and the pump runs fine and nothing shuts down. So that being said, everything looks really, I'm happy with how this looks now. I'm happy with how this functions. The hue of this light is still a little bit off, and I'm not really sure what the deal is. I think it might be the voltage difference because we're running on battery power, but I'm not going to concern myself with it that much on this version. So what we're going to do now, I've already started sort of assembling the parts onto a little prototype card, and I'm going to solder everything together. And then I will test the board and mount it onto, I guess the frame would be the right thing to call it. So yeah, this is going really well. Let's see if this works. It'd be really cool if this works right off the bat. Okay, ground is in. Positive terminals in. Let's see. Weird. Okay. Oh, I bet I didn't connect the ground. Jeez. This is so much work. I gotta take a break. Okay, this is great news. This means the Arduino is getting power. The LEDs are set up properly, which is good. Oh, I'm real happy with that. This is good news. The blue LEDs are really bright now. Let me decrease. Okay, so the startup sequence went really well. You can see this is red. The variable resistor is working. That changed color. Oh, this is really good. This is good. The LEDs work. This works. We're gonna plug in the solar panel and the pump. The relay works. This is great news. Here, I'll be real quiet. Super. So I'm just going to plug everything in basically. So this is good. All the hardware works now. We're going to plug in the solar panel and see if the charge controller portion of our circuit, which is kind of crammed in this bottom corner there. There's the Zener diode and the... This is the last time I'm hand building these boards. It's cool to do, but honestly, the result's kind of messy and I get tired and I make little mistakes down here and then I have to debug them and then I have to fix them. So I don't think this is how I'm going to do this anymore. And what I hope was the last physical change I have to make to the circuit, which I think this is the 5th time I've said that. Okay, well, it's working. It's very responsive. It does what I want it to do. This is really good news. I'm very happy about this. Pump. Don't pump. This is great. This is also running entirely on battery power. I have verified that the solar panel is charging at a very small rate. And it is charging the battery, so the charge controller portion of our circuit is functioning as expected, which I'm very happy about. Yeah, so the next thing I'm going to do is I'm going to clean up this workspace, and I'm going to assemble everything onto this chassis and sort of remove what remains of the debugging, like this wire harness and some other things. And I think we are done. I mean, I think this version of the project is done, which is super exciting. I'm really happy about this. So I'm going to clean that up and then we'll do a wrap up of the video. Okay, and here it is, the finished product. I've got everything kind of wired up. It's sitting on the chassis. I sort of had to use these little risers because I was worried about sort of crunching the underside of this. So I use little risers so it sits off of the chassis, but that's fine. And then everything, the battery, the solar panel, the pump, everything is wired in now. And it's sitting here happy as can be, or I'm happy. I'm really happy about this. I've got the soil moisture sensor here in the soil, and then I've got the water spout in there too. And here we can do a little test here just to show the functionality. So let's make it there. We've increased the threshold. We're asking it for more water. Great, it's pumping in there. We will tone it back a little bit. There we go. Man, I am so happy with this. This this is really cool. I'm glad this is done. Additionally, in the video description, I will post links for the circuit diagram, the real circuit diagram, and the code that runs on this.
You guys are welcome to clone it and look at it, comment on it, whatever you want. So, yeah.
Okay, so the project's done now, and I'm pretty happy with how it turned out. This was fun to build, and I'm really glad it works. It's been running now for a couple of days. It hasn't been sitting here, it's actually been sitting near a window. But it's been running for a few days, and the battery is holding itself charged. It's kind of going into a sleep mode. After a while, there's an exponential back off in the code, so it checks like every 10 minutes, and then every hour and 6 hours, and then only once a day. So it's been maintaining its power levels pretty well. It's been keeping the plant watered. It hasn't overwatered it and like flooded over the sides. There's still a fair amount of water left in the reservoir. So, I mean, overall, I'm super happy with how this project came out. In reflection though, there are some things I would definitely do differently. The first of which is the form is kind of funny. Like, I don't know why I didn't think about this, but it definitely looks like a prop from like a B action movie. So I think I would do something different with the form. It's really fun to build these by hand, but it's super tedious and it's pretty error prone. I had 3 or 4 instances where I had soldered some connection incorrectly and I had to debug it, and it was really frustrating. So I think from now on I will design the circuit, test it on a breadboard, make adjustments, and then send that design off to a PCB manufacturer and have them mail it out to me. I think that just makes a lot more sense. Other changes, I think I would consolidate the moisture sensor and the irrigation tube so they're just like one unit, so it's a little cleaner. Maybe integrate everything in the nozzle in one place. That would be a cool improvement. Maybe even a smaller pump and battery so that the whole thing has a smaller electrical footprint. But I'm happy with this. I'm really happy with how this came out. So yeah, I hope you guys liked the video, and I'll see you guys next time.